start out like this. I hope everybody enjoys the conference so far. It's easy to choose one track, sit down, listen to the people, so I'm hoping that I can get you enthusiastic for WebAssembly, because in the next 40 minutes, I'm going to talk to you about how you can use WebAssembly to run, extend, but most of all, secure your application. So, there are different aspects of WebAssembly in general that are pretty good, and there are some technical details that we're going to go through. So first, let me briefly introduce myself. There's a lot on this slide, but I work as a security researcher, Niels, as a security researcher for Verco, and I've been doing .NET development and security consultancy at Hacking for a while now, and right now I'm focusing on static analysis, so the stuff that you saw Frans talking about this morning, that's what I do, but then I do it for Verco. And I'm also a Microsoft MVP, where I mostly talk to developers and talk to people who write software, because I think technology should be cool and everybody should be able to use it in such a way that we write secure software for everybody to use, right? Because that will be beneficial for everybody. If you want to see more about Verco, there's a table that we have, our booth is over there. Make sure you go there after this. I would appreciate that. That's enough Verco, right? So, WebAssembly. If you look at when it got introduced in 2017, we had the first release, and that's also called an MVP, but that was like the minimal viable product of WebAssembly 1.0. And it was released in the 4 major browsers, right? And it has been defined as a portable, efficient like runtime to run inside your browser. And it's also one that's pretty secure by default, and it's a compilation target. We're going to touch that in a bit as well. And I mentioned, I'm not sure if people were in the room when I had my slides up. The title, the working title, I normally have like using WebAssembly to secure a .NET application or extend, because I'm a .NET guy. But we're going to touch all the technologies, because that's the powerful stuff that WebAssembly gives us. It's a target you can use in a lot of ways. So when I got introduced, 1.0, what happened? What was the first thing we saw? And if people are familiar with AutoCAD, it's that drawing software that engineers use to do building stuff and maybe do some construction calculation and make sure that, hey, if you extend this house, you put this in, that kind of things. They took their C code base, and with a tool called Mscripted, they were able to compile it into WebAssembly. And then AutoCAD could just run inside the browser. That's what they did. So that was the first things we saw happening with WebAssembly when it started out. In the context of a browser, you were able to use tools that were around for a long time. This is nice. What else happened with WebAssembly after that? And I think this is something that everybody uses on a daily basis. So both Disney Plus and Amazon Prime use WebAssembly to do all the video streaming apps. And they are able, as Amazon always states over here, it's like they're able to target 8,000 devices all at once because of WebAssembly. So if you're using Amazon Prime Video or Disney Plus, it will always look and feel the same on every device that you're using. That's because of this, right? So WebAssembly is used as an SDK for SDKs in order to have quick adoption, to be able to use it, and it literally runs everywhere, right? I'm not sure like most of the people will have a television that's maybe based on Android TV or Apple TV, right? Or maybe one from Samsung or Tizen. But being able to have one code base and just compile 4 different things based on WebAssembly, that's quite powerful. So they leverage it in such a way, which was pretty neat. And that allowed them to quickly release and be more agile in the way that they approach things. So what we're going to do next up, right? This was the history of WebAssembly. I want to dig into some WebAssembly 101 and explain to you why I think WebAssembly is a target that is really secure by default and how it works internally. We're going to look into how it deals with memory and how it deals with execution of stuff, right? So that's all the security things. Then we're going to move into running apps. I'm going to show you like, hey, you can do .NET on top of WebAssembly because I'm a .NET guy, but we're also going to look into Python that does exactly the same. So there are some demos in it. And then we're going to use it to extend and secure and look into WebAssembly and the runtime as it is and see that it has pretty good defaults. And in order to achieve stuff, we need to explicitly mention to the runtime you're allowed to do this. And that's quite powerful. It gives a lot of leverage. And then at the end, conclusion and Q&A, I'm of course around the rest of the afternoon as well. So, looking at the design that was made, WebAssembly needed to be fast, efficient, and portable, right? So it needs to run everywhere and almost near native speed. It needs to be readable and debuggable. So there's a bytecode representation if you look into the stuff, how it gets loaded on your machine. But there's also a text thing you can just read. It makes it powerful. It needs to be kept secure. It needs to run in a sandbox execution environment. If it runs inside the browser, then if it's same origin policy that's applied, right, it will rely on all the normal stuff you will get if you visit the website, right? And yes, there's probably problems in that space as well, but by default it's that. If we want to take it outside the browser, that's a different story, and that's one of the technology things we're going to look into. The other thing that was really important, that it should not break the web. It should be backwards compatible. I'm not sure if from the old days, if we had browser bars, if somebody introduced a new feature that was maybe a bit different than the standard would like it to work, then you'll break the internet, you will lose users, right? That's what happened with Firefox, Chrome, Netscape, right? The old days, that kind of thing. They don't want to break the web, which is, from security perspective, also still a problem to stay backwards compatible, right? It's a tough fight. But that was also in a design. They want to make sure that they're backwards compatible in the whole thing. And if you look at it, how it works, it is a instruction format for a stack-based virtual machine. And if you're doing .NET or Java development, it's the equivalent of running IL on the CRM with .NET, or if you run bytecode on the GVA. It almost is the same. Compile runs once, you're in there, right? That's what they also said with Java. And WebAssembly also has that as a goal. And should be defined as a compilation target, so you can write Python, Rust, Go, .NET, target it as a WebAssembly module, and then run it. And the model itself, it should protect users from buggy or malicious modules. If you look at stuff that's happening right now, supply chain attacks, the library gets compromised. I want to safeguard people that use my software, and I also want to reuse stuff that's already there. Because I'm lazy, I'm a developer, I want to not reinvent the wheel, but I also want to make sure that if something happens with a library, then users are safe, right? And it also needs to help out providing developers with useful primitives. And what I mean with that is that the default API should be guiding somebody to make the right choices. And if it's a choice that needs to be like the opposite, within .NET, I'm sorry, I'm going to use an example again, but if you want to disable certificate validation, the handler you register is pretty much saying like dangerous handler. That's to a degree how it's called. So it makes it explicit. You need to do it. And that makes it easy and hopefully intuitive for the developer to make the right choices, right? So that was also one of the goals that WebAssembly had in general. But enough said about design. What really is a key thing within WebAssembly modules is memory and how it uses memory. So each module that gets loaded, the concept of a module, we're going to see more in the next slides, but will be isolated and it will have its own contiguous mutable array of interpreted bytes. It's just a piece of memory that it can use. The blue drawings you see over here are the ones from code cartoons, and code cartoons are done by Blink Clark, and she's part of the Bytecode Alliance. Bytecode Alliance run a lot of the WebAssembly standards. But you're going to see a lot of those drawings in my presentation. All the links and all the stuff I'm pointing out to are in a repo at the end, and it has the slides and the notes for you, so you don't need to keep track of it. But those blue cartoons are being done by Blink Clark. Pretty cool. She explains a lot on how stuff works. So, because a module can only access its own memory, another module, without any help, cannot access that memory of the other module, right? It cannot do stuff. There needs to be help from outside in that perspective. We still have the problem that a module itself might have got a bug or a problem that will mingle with its own memory, right? So if there's a thing that somebody can do, then that might still be a problem. So what can we do in order to safeguard that from happening? So on top of memory per module, we also have something called control flow integrity. And I need to explain it, so why not take some C# code, being a .NET guy, but if you read through this, it's not like you need to be advanced, but it has a code path. It has a code path through it, right? So what I'm doing here is reading a number, then I'm going to say writing out the number to the screen. Condition is going to say, hey, if the number is greater than 5, then I'm going to point it out to you that it's greater than 5. Otherwise, the second command will be executed. And then at the end, stuff comes and it says done, right? This is a step-through thing, and it has some logical paths in it. It can be redrawn as this. We have the first block that will always execute, and then we end up in the decision-making of if else, right? And one condition will go to the left arrow, the other one will go to the right arrow. And that is a map, and that's something you can write down. So what WebAssembly does at compile time, it will create a map of possible execution paths for control flow integrity. And if then at runtime something happens, it will stop executing and it will run into a trap. I'm going to see one of those in the demos as well. It will stop executing. So that's quite powerful, right? So we have memory. being able to be isolated per module. And with this, on top of it, we took care of a lot of security issues, right? And that's nice. It's not going to cover all, but the base is really good. It's even as good as the following project. This is one, I'm not sure if you're able to read it, but this is called RLBox, and it's inside the Firefox browser if you're using it right now. So what they've done, and this is I was reading through it, this is pretty cool. They've taken C plugins that they use to render fonts and media inside your browser, and they said like, okay, if we compile that C code into WebAssembly, we can safeguard a lot of the stuff that we have, like with memory, like with leakage or with overflows, underruns, whatever, right? But we can make sure that those plugins are safer because WebAssembly would help us out with memory per module and with the control flow for sure. That's cool. That's what they did. Then they decided we don't want WebAssembly modules inside the browser when we deploy it. We want to have a single code base. So then they took that WebAssembly modules and converted them back to C code in order to integrate into their code base. Meaning that they have C code, it's single, but they will use all the language features I just talked about with WebAssembly and put it back in the C code space. And what they also did is pretty cool, was they were able to introduce some data flow analysis, as Frans explained this morning. If a plugin or an extension gets run, the data that goes into it has like a gate where it goes to, and then the data comes back from the plugin that gets rendered. And you need to explicitly encode, make sure that the data is safe before you use it. And that's the thing that it helped out. It created some kind of stopcode, and it will throw an error if you don't have a validation routine for the data that comes back. So they leveraged WebAssembly. So you're not running WebAssembly, but they used it as a compilation target to get back to C and to safely execute it. I think this is pretty cool. This shows the power of how good WebAssembly is as a language and how it can mitigate a lot of things. So even if you're doing maybe some data stuff on Jupyter Lab, for example, this will run Python inside your browser, and it will run Python on top of WebAssembly. If you look into what gets downloaded, and I'm hoping you're able to see it, maybe it's a bit too small, but you see at some point that there is a Python.wasm file being downloaded, and that's the Python runtime that it used to execute Python inside the browser. And you're able to do that with the notebooks and do all the data mingling you need to do, right? That's the reason why it works. So they've taken the Python runtime and moved it into the browser to execute. If we look at .NET, and this is a conceptual drawing, I will explain to you briefly what it is. We have code that we write ourselves, right? Source code, in my case, user code, which will turn into IL. We have the base class library, which is system.io.file. I need to open up files, or I need to go to the internet with an HTTP client to get data back to my system. And then we have the execution engine, or VES, which in this case is the runtime, or the CLR. How can we get .NET running on WebAssembly? We replace the execution engine, and that's exactly how they started out at Microsoft, by taking the mono C code base of the CLR and moving it to WebAssembly by mscripting again. That's the tool being used. They created a concept for you to run WebAssembly or to run .NET on top of WebAssembly. And if people are familiar with .NET, Blazor WebAssembly, that's exactly what I'm talking about here, right? It will download the WebAssembly runtime version of .NET, and it will download also the DLLs of the application itself that it needs. So pretty cool. But then, as I said, this is all browser-based. This is not cool stuff. This is not new stuff. So what do we need to do in order to get outside of the browser? Is, of course, we need to eliminate the browser. We need to put something in place in order to be able to interact with stuff, right? If you do Blazor WebAssembly, you cannot open files on the system because it will open up the dialog that the browser has, like, hey, file picker, if you want to do that, you're restricted in that way. But I want to have maybe access to systems. So the Bytecode Alliance introduced a system standard, or WebAssembly system interface, or WASI, in 2019, which they said, like, hey, what if we abstract that whole layer and make it into a POSIX-inspired, engine-independent, non-web system-oriented API for WebAssembly? Long sentence, but they have taken that layer out, and they said, like, okay, let's also introduce a runtime that we can use, WASM time, as a reference, to explain how it works and how it runs. And what about if we were able to do sandboxing with capability-based security? And now it gets cool. So right now, I'm running a lot of Preview 1 bits, as how they call it, and they're pretty close on releasing Preview 2. But by default, the WebAssembly sandbox cannot do anything. I'm going to show you that. And you can limit access what it's allowed to do. And in future support, there will be also stuff for for sockets and other system resources, as we will see later on. And people who are familiar with .NET standard, it's that unification of base class language into a single thing. This is almost the same, but then for WebAssembly runtime. And how important is this movement to WebAssembly, or WASI? So Solomon Hykes, you probably know him from a thing called Docker, tweeted this when it was released, saying hey, if it would have existed in 2008, we would not have no need to create Docker. That's how key thing this is, right? Because it will have influence on how cloud workloads and how stuff will be executed. And this was one day, and then he probably got a lot of angry phone calls, because the next day he got this tweet out saying hey, will it replace Docker? That was probably a touchy subject, and that's not the case. It will run side by side. And if we then look at KubeCon last year, like a year ago, that's exactly what we saw here. Docker will run containers, but will also run WebAssembly modules, which are much smaller pieces that you can execute in the same thing. So that's pretty cool. And I think that shows that this is a technology stack that can be quite valuable. Getting back to .NET, we can do exactly the same as I told, and now we're going to move into .NET. And as I said, Python, we're going to take .NET application and run it on WebAssembly. And with .NET, they released an SDK that we can use. So let's move into some code. And I need to make sure that I get out of my presentation, otherwise you won't see anything. So the project is pretty simple. It will pull in a package that will do all the compilations for me. And this is just a simple console app that will say, hey, good afternoon to everybody. And then we're going to point out to what the OS architecture is, where this application runs on, right? So if I now do this, I'm going to build, just to make sure that it works. If I now take the binary, that's the .NET binary, and execute it, you will see over here at the bottom, maybe I need to put it up a bit, but you will see that my system says this is an ARM64, this is my MacBook, where this is running on. But if I do it in the WebAssembly context, and that's the .NET Run for this type of project, you will say, hey, it's running on WASM. So this is the same app, but it has two different ways of getting executed. So what if we want to do the following things? I was talking about no access anything, right? So, hey, I want to read some file contents of my system. I'm going to say read all text. And let's say I want to do it from my etc host file, which has no secrets to you, hopefully. And then, otherwise it's fine. You're going to see it's localhost something, I guess. So, and then let's write this one out to the console to see. So it says, okay, cool. 5 fingers, make sure I do a .NET build. If I now do a .NET run, you will see it will miserably fail by default, because it says hey, I want to open up a file, but I'm not allowed to do it. If I take the .NET binaries that I compiled before, so that's the known WebAssembly version, you will see it will just read my file from my system, right? So there's that layer in between that allows you to limit stuff. .NET Run does WASM time. So WASM time is a runtime that you can just take and execute stuff. And I need to make sure I got the right one. So if I now say to this, hey, run this WebAssembly module, looking into the content, you will see that the .NET application is converted to a single WASM file. But it will run .NET. It will take those DLLs out and execute it. If I now granted access to that system folder, like providing him the argument saying hey, you can open up this directory, you're able to see the contents, right? So by default, it has no access. And by explicitly me mentioning hey, this folder needs to be readable, you can do it, right? This looks pretty promising if you look at it from a default perspective. So, as I said before, there's also a Python version, just to make sure that I'm not joking you on things. So let me open up a code window in this directory to show the file. Hold on. So what I'm doing here is almost the equivalent, right? I'm printing out the platform that this Python module runs on, and then I'm going to try to open up my etc host file and print it out. If I now do a Python 3 and then say this file, it complains about the fact that it's not there. Hold on a second. Yes. WASM time. So Python itself needs to have access to the directory that it runs in. That's the default. My WebAssembly runtime just failed me because Python needs to load files and I didn't grant it access to its own directory, right? So by default, it's locked down. If I do this, you will see that it's not able to read a file. Okay, cool. Not sure what happened. etc hosts should be there. And that's because it has no access, right, to that file. If I now do the additional dir and say, hey, open up etc as well for me, you will see that it still fails. Trust me, this works. If you go to one of my demos. I was talking about this before, like doing demos. It's always calling the demo gods. I need to do wasm time, run. This is the Python wasm. Let me see for sure. This is the default one. It should not have... Oh, hold on. This is the wrong directory, people. This is the wrong directory that I'm in. Hold on. Should be fine. So this is the right one. If I now do wasm time run demo, you will see, hey, file not found because I cannot access it, right? Now I'm going to do the other one. Reading it. Now it reads the file, right? So, yes. Yes. I was talking about demos failing. That shows that you're human and that you have fat fingers and you can fail. But this shows that this is the default, and if you want to have access to stuff, you need to explicitly grant it. I'm going to move on to the next demo. I'm not going to go back to a single slide and then show you and explain to you what the next demo is. So I said you were also going to extend a web application with WebAssembly, and now we're going to take the WebAssembly runtime and run it inside our .NET application. And you can just grab it by adding the package. And then I have a Rust module, and let me quickly show you what's inside, because I want to take that Rust module and run it inside my .NET application, because that's one of the things you should do, right? It's a compilation target, and you should be able to run any technology inside of it. So this is, funny fact, also doing files with copy files, right? That's what it does. And there's a main method that will take the arguments that will try to copy file from point A to point B. So you can probably guess where I'm heading. This is the module that will execute, and then we have the host that will run it. And now we're going to do a bit more with the whole capability-based thing, but it's easier in code than doing it at the CLI level. So let me open up this project, make sure I'm in the right folder, because otherwise I'm going to fail again with the same demo. So close this one up. Hold on. So yes, there's a lot of code, and you probably see the stuff that I'm doing demo. Is this something you would do in production? No, but at the end, I'm going to point you out to some of the component work that's being done, which will make this a lot easier and just some tooling that you run. But it will give you the same capability-based things. So what I'm doing here is I'm taking a WebAssembly runtime and I'm just linking it up, making sure everything is available. And then I'm loading my Rust module. And then I'm instantiating it, right? And then I'm executing it. So this is the default. If I now do a .NET run and I say, I want to take my etc host file and copy it to host in the current folder. Then it says, hey, you want to open a file. So this is the .NET application that starts the Rust module, that executes and that gives back this error. Could not be opened, right? So this is exactly the same thing. Pretty cool. So how can I grant it access? I can say, okay, you need to make sure that you're able to read that folder. That's that whole POSIX sandbox, right? I want to make sure explicitly that you're doing this. And because I'm writing files to the current folder, I need to grant it access to the current folder as well. Because as you've seen with the Python demo, it doesn't have it, right? Directory. Oh, yes. Let's do this. Cool. This should be fine. So now I've configured it to have access to those files. So if I now say .NET build to make sure I'm not done anything wrong, now I'm doing a copy, and you will see that it won't be opening up etc hosts. What did I do wrong? Let me see, did I not save the file? Hold on a second, I think that's the case. Yes, red dot, there was still a dot behind it. If I now do a .NET build again, just to be sure, and if I now do a .NET run, it will copy, right? It will copy the file because it has granted access to it. So this is the same demo, but you can see that if you have a module that you don't trust, you can build up a sandbox like this. Is it practical? No, but it shows the potential of this technology. The other thing can also do is there's a concept of fuel. So you can limit its memory as well. You can say it's only allowed to consume this amount of memory. If you know that it don't exceed X amount, then you can do it. You can also do something with fuel. Fuel is the amount of compute it uses. and each tick will consume up a certain amount of fuel. And we can say, okay, let's limit this runtime and say it can do 50,000 fuel executions, and then it needs to stop. So if I now make sure I save it by closing the file and say .NET build and run it again, let me get rid of the file and then run the other one in that we did before. You will see it gives us more output. It says it has consumed 35,000 x fuel. If I now limit it to say it can only do 500 ticks, because normally I would consider that's normal to execute stuff, you will see that trap that I mentioned to you before. Is this saved? Closing the file. Oh, I'm going to be neurotic with this. And then .NET build to make sure that my code isn't failing. Run, open up the file. Let's make it host2 file. And now it will fail, right? And this is the trap that I talked to you about. And it stopped executing because I instructed it cannot do more than this. So those are two capabilities that you can limit. And yes, a lot of code. Is it practical? No. But it shows the potential, right? And I think the fact that you've abstracted away all those system resources, the developer can probably exactly tell what needs to happen at a certain point in code. And yes, you always need to configure apps, limited privileges, that kind of thing. It all needs to fill in, right? It all needs to make sense. So there's a lot more to it, but I think this is pretty cool. Let's move on to the next security thing, which is called trusted computing. And this is probably you know these cartoons, right? XK, CD. This shows the modern tech stack, and these are all the layers that you use if you run stuff inside the cloud, if you run on some kind of cloud provider like Azure or AWS or Google Cloud for whatever. You have the former employee that might be a risk. You have the nation state somewhere at the bottom that will take the hardware and do funny stuff with it, right? So this is the thing. The funny fact is that there's a project started called NROX, which is confidential computing with WebAssembly. And it runs a WASI-compliant WebAssembly runtime on a trusted execution environment, which is a small section of processors. Intel, AMD, you have certain parts of the processor where you can run it. And NROX is an open source project, used to be run by people that worked at Red Hat. Unfortunately, the company that was doing the supportive work, so there was also a commercial counterpart of it, they stopped business, but the project is still there. And it's pretty powerful. I was like, oh, sure, do demos, but this is just the WASM time implementation, but it only has different internals. So what they do is hey, this is a threat model. We don't trust the host. We don't trust the host owner. We don't trust the operator. We want to make sure that the hardware that we run on is cryptographically verified. So chips are like signed with keys. You can check it. And they also are able, because NROX itself is a runtime that's written open in the public, everybody can review it. So you can have it audited, and you can also check heuristics of the runtime and make sure that it's secure. So what they do, and this is a technical thing, right? So there's the AMD version, Intel and IBM have got their own version, but they replaced that, and this will be run on a much lower level of your CPU, but it's trusted computing. And this is cool, and it's WASI compliant. So everything that compiles to WASI can run inside of this. You can imagine that if you do sensitive data transitions in the cloud, then this might even be a good default to do. And that's exactly, as I said, NROX, the project is still there. I'm hoping that they will continue doing this. But if we then look at what Microsoft is doing, and I'm a guy that keeps a close eye on what Microsoft tells, right? They have a project called Hyperlight, which they use to do different types of virtual machines, containers, but also WebAssembly modules. And what they've done is they've taken all the stuff I just showed and moved it into a product, and they showed that they can isolate WebAssembly by running WebAssembly inside of .NET and then run .NET on top of it. And they have a really cool program model, which is a concept that's done by Steve Sanderson, who's the guy that also did Blazor. But on the right-hand side, you see one of the developers talking about how they think that a hypervisor layer can also add up to a sandbox for WebAssembly runtimes. And it can be really useful for confidential computing. So this also shows the move, like, hey, if you have a WASI-compliant module that runs, then confidential computing is easy. And keep in mind, like, a Docker container will be a couple of hundred megs, and a WebAssembly module, depending on what's inside, but a couple of, let's say, 5-6 megs, is definitely doable, right? It's much smaller, and it can be much more scalable, and it can be run close to the data as well. So this has a lot of potential, right? But then looking into WebAssembly and what's next, I think 80% of the code base, and this is of course up for discussion, is somebody else's code, right? And if we have dependencies and a list of transitive dependencies, there's one on the top, and that will grant access to every module that uses it. In .NET, it's the same. The process starts that every module underneath that, every library will have the same access to the system unless if you lock it down. If you want to have limited access, you need to move to a separate process, right? Which might be hard, but that's the default. What if one of the modules become malicious, right? People get that nice mask on and will say, this is a malicious module. I want to look into system tables. That's a possibility. What if there's a vulnerability in that module? If somebody is able to control it from the outside and do bad stuff with it. How can we safeguard this in a better way? We could isolate it, as I said, processes, right? So these are two runtimes with two transitive dependencies trees. And in order to do some stuff, you need to have some IPC communication between those modules. Like this is how your browser does it with tabs, like to communicate with each other. You need to do some stuff for it, right? But there's a lot of overhead. And if you're only talking about two WebAssembly modules, then it's a lot of overhead for two small pieces to communicate. And the thing on the bottom says like this is not drawn at scale. It's a funny joke, but the nano process is the thing I want to move into. Because with WebAssembly, we have that sandbox, right? So we have something that's in control of what you're allowed to do. What I showed you before. It can only access its own memory. It can only access the section of its memory that it's allowed to use. And if it wants to interchange stuff, it needs help. And that's what you see here. So somebody else is in charge of dealing like who's able to access something or not. And the whole systems interface, like file, system access, and so on, can be limited as well. As you saw in the demos, you can say this is what you're allowed to do and this is not what you're allowed to do. And if there is like a module, so the thing that starts out the process, it can delegate and say, hey, you only need to have access to this part of the file system, or you need to be able to stay within this bounds of memory and do less compute. It will all be a layer of defense in this whole story, right? And that's where the WebAssembly component model comes in. And this is something that was talked about. So Luke Wagner is one of the guys that runs this whole thing. He works at Fastly as one of the engineers. And he explains exactly how he sees the whole component model and how it works. And right now they're close to do preview 2. But this project, if you're interested, WASI-FIRT allows you to do that whole capability-based stuff and wrap a component with a limitation of you're only allowed to do this and then use it as a component. And this is the next step forward. And there's others that have shown tooling that you can use and also with drawings and connecting dots that does exactly the same. It's powerful. So preview 2 should be there. They told, I think in October, they said the next 6 months it should be there. Then I need to revamp all my demos and hopefully I can show a bit more workable version of doing this. But as I said, I think it has potential. But then getting back to, I've been around a while, we have all seen this, right? Is this exactly the same? So it has nothing to do with distributed computing like Orba or DCOM. And if people are running .NET, like the whole capability-based thing, .NET framework security, code access security, that was the thing that we had in the early days. It was a bit too early because you could just switch it off by mutex in memory, right? That's a different story, but it had a lot of potential as well. So, and one big disclaimer I still want to make is that it will be as secure as the runtime itself. And if you look into what Bytecode Alliance tells about Wasm-Time, they have a pretty open security process and saying like, this is how we work with Wasm-Time. We make sure that it's written in a language, in this case Rust, that will use all the language security features I just showed, right? Control for integrity is part of it as well. They do continuous fuzzing of those runtimes. And they have a good disclosure and security process to keep stuff in place. So that's nice, and they show you. And if you're a bad reader and you want to listen to, this is a talk of a guy that runs it inside the Bytecode Alliance. And he exactly explains the whole processes on how they deal with security issues. So I'm going to wrap up because I'm almost running out of time. So as I said, cloud native, if you look at it in general, I think WebAssembly modules, you're going to see a lot more of them. It has a lot of potential to be used in the right context. But keep in mind that it's as secure as its runtime implementation. All security research that I've seen presented at Black Hat DEFCON was always focusing on fuzzing runtimes and finding stuff in that. In general, the whole thing, how it works, it's pretty solid, and it's good that they're focusing on the runtimes, as I said, because that will still be the Achilles heel of all of this. But I like the whole way that Bytecode Alliance is saying, like, hey, we're doing this conceptually and then showing it to people, for people to use. And there's some pretty cool stuff happening with companies like Fermion or Cosmonic or even with bytecode lines wasn't time that you can look into if you're interested in this. So the almost Benelux repo, it's not there yet. I need to commit it, I need to create it, but it will be there. It will contain the slides and the demos and a lot more demos that I have. If you want to reach me on email, there's the email address, or I'm on Mastodon as well. And I'm going to say, merci, thank you, and enjoy the rest of the conference. I think I got 2 minutes for questions, right?
We have time for a few questions.
Cool.
Are there any questions, or is it all clear?
There's a question at the back.
I have a question. What's the typical overhead if we're talking about use another layer?
Yeah, what's the overhead? It's less than a Docker runtime. that's a political answer. Yes, there is overhead. If you look at the .NET demos that I'm doing, you can do .NET on .NET. And I think it's like if you do that, that's a double layer even, right? I don't know the exact figures. There's probably something, and it will be overhead, but it's quite minimal. It should be as minimal as possible. The exact numbers, I'm let that sit with it. I'm going to get back to you on those numbers. So we'll up front, and then we can see details. Good question.
Any other questions?
When you use the Docker, in the compose file, you can define what is the network, what's in between.
Yeah.
Is there something here also that allows you to control it?
Yeah. So to repeat, like, can you control WebAssembly modules in the same way that you can control Docker containers by saying no egress, it cannot go out to the internet, right? Yes, the stuff that I showed is all based on code. They will have a descriptive model, which is like a definition language they call WIT, which is like an interface where it will describe, like, this is the module that I'm running, and it will only be allowed to do this. I think it's just, I think it's a YAML document. And it's going to leverage cloud. It's going to be, the modules are going to be in container repos in the same way, right? That's what they're aiming for. So yes, it should be there. It should be tooled, otherwise it's almost impossible, like, doing all stuff by hand, right? That's not how it works. So, okay.
That's all the time we have.
Thank you.
Thank you very much, Niels.
Yeah, you're welcome. Thank you.